All right, but it looks like we're successful. So let's share screen. All right, welcome to Plutus Project-Based Learning 2024. It's the 22nd of May, 2024. And this is the launch of basically our fifth iteration of these live coding sessions here at Gimbalabs. We've been doing this since late 2021. We've been refining this course together for a couple years now. And the brand new version of the course, 2024, went live last week and will continue to roll out through the end of June. There's a website here for anybody who's watching this video and wants to get started. It's plutuspbl.io. And you'll find a few things here. One is links to the Gimbalabs Discord channel and the Gimbalabs GitHub, where you can find a lot of resources. There's links to different Git repositories that we're using in this course. And there's also links to our live calendar, where you can find Zoom registration links to sign up for meetings like this one. We meet to talk about Go specifically on Mondays, Mesh on Tuesdays, and then we have Gimbalabs Playground also on Tuesdays. On Wednesdays, this is the Plutus PBL Live Coding session. And on Thursdays, we run an open spaces session where the agenda is wide open. And we often talk about Gimbalabs governance and what projects we're going to be working on. So that's an overview, but we are here to really dig into the PPBL 2024 course. And you can access it. There's a link right here to the live course on Damio, where you can see that over the next couple of weeks, every module of this course is going to be rolling out. So we published the first module. It's simply called Getting Started last week. And it had a couple of learning targets, which we'll talk about in just a moment. And just today, module 101 was published, the 22nd of May, which covers compiling validators in a couple of different languages. And we'll jump into these lessons for a moment as well. Does anybody have any questions about this initial set of resources, whether it's the Plutus PBL companion site at plutuspbl.io or the course that's on my screen right here? Okay, so in the first module, there's videos for all of these lessons already. You can click the button that says Start this module, or you can click on any learning target to jump straight to a lesson. And you can see right here, there's embedded video content for each of these. What we do in module 100 is take a look at some of the live examples right here. And I'm not going to go through these again because I don't want to ruin the surprise for anybody who hasn't done this yet, but it shows you how to connect a wallet. It shows you how to mint an access token that we'll use in this course. And it shows you how to interact with your first application on Cardano. All of the source code for this example that you can see right here, you can find it in course repositories, PPBL 2024 front end. And these examples are here because we're going to continue to look at them in different ways throughout this course. And that's exactly what happens in module 101, which is live today. So in lesson 100.5, you get to interact with something that we call the PPBL Faucet. All right. It allows the holder of a token to get some other tokens from an address automatically. But we don't show you how this works. And to show people how this works, there's a couple of things we're going to have to do. And all of that's going to be covered over the next several modules. So in module 101, which we're going to jump to right now, you'll learn how to write the validator code in several different languages for the PPBL faucet. In module 102, you'll learn how to build transactions that allow you to interact with this faucet. And finally, in module 201, we will show you how to actually, how we actually built this page right here and all of the source code behind it. Okay, so we start with an example, and then module by module, we build up to helping people understand how that example works. First with validators, then with transactions, and then with the front end code. Does anybody have any questions about the story that we're trying to tell in this course as I kind of laid it out there? Okay, if not, let's jump into module 101, which is brand new today. I'm going to navigate actually to the intro. And there's an introduction here that's a little longer than the typical intro that takes people through this question: what actually is a smart contract? And it introduces the idea that really we don't have a technical structure. There's no data type called a smart contract on Cardano. Instead, we have UTXOs, transactions, and validators. There's a bunch of other stuff we need to know about, but at a high level, it's hard to get started with Cardano development without understanding these three things. So this introduction walks through these concepts one at a time: UTXOs, transactions, and validators. And just like anything in this course, this content can be updated over time. And this is where I really want to lean on everybody here on this call and all future students of this course. If you see something in this document right here that doesn't make sense, please let everybody know about that. We can talk about it at a live coding session so that we can improve it. We can talk about it in the Gimbalabs Discord, or for anybody who's participating a little more comprehensively on the Gimbalabs team, we now have a Notion board where we can talk about feedback on each of these lessons and modules here. So what do you think, first and foremost, this claim, right? Instead of thinking about smart contracts, one of the first things we tell people is, hey, you got to know UTXOs, transactions, and validators. Would you say it a different way? Or is there anything you would change? Would you add something to this list? Does one of these not belong here? Any feedback on this part?
So
James?
far, so good.
Yeah, Claudio.
Yeah, I agree with that. That's exactly the major difference between Cardano and every other blockchain. I mean, the account-based models. What I was thinking of is that a smart contract actually, instead of there's a little difference between transactions and what you offer in the front end, which is a transaction schema that then you actually instantiate to produce complete transaction that you submit to the blockchain. But at this stage, I don't think that distinction is too relevant. It's just a little, comb in the hair, if you.
I really like the way you said that. And that's right. There actually was once a technical structure called contract. It was the contract monad in the Plutus application backend. And what was that monad in particular responsible for? It was basically to provide us with that transaction schema that you're talking about. So I really like the way you said that, Claudio. And I've been going back and forth, right? Like, is there a way that we could say that right here that wouldn't totally confuse people who are brand new to this material? I haven't figured it out yet, but I think
No,
that,
that's what I think. I was thinking that at this stage, it's better to leave it like that. And then, like, for instance, I'm going to talk a bit about that in my presentation on Playground. But you need to have some hands-on experience with these notions, just playing with them, to then put them all together in a more conceptual way, you see? So I think this is fine.
ooh, so your playground presentation in a couple of weeks is going to be a nice companion piece to this course, and we can probably even link to it.
We'll
That's
see.
really
Hopefully,
Yeah, we'll
hopefully
see
it
how
comes
it
out
goes.
okay.
But that's very cool. Thank you for thinking about that. And let's remember when we get to the point of writing the lessons for Module 201, let's try to incorporate that point into the course. I think that's really good. What else? Hinson said so far so good. Anybody else? Okay. So that's our introduction. The other thing that's live is if we move forward to the very next lesson, this one jumps into the faucet. And we show the faucet source code for the first time in Plutus TX. And this is one of the biggest changes from last year to this year's version of the course, is that we're no longer going to try to help people set up a local Haskell and Plutus TX development environment. I really do want to survey students of the course to find out who wants to do that. And if there's a critical mass of people who do want to run the Haskell Plutus TX stack locally, let's make sure to help people do that. But until there's demand, let's not add that to the course. That's the decision we made a couple of weeks ago together. And it feels really good because that was the feedback we've gotten in prior years is that can feel really frustrating if we start there. Instead, and I shared this in the Discord yesterday, we now have the ability to just spin up the PPBL example repo for Plutus TX directly in Demeter so that people can start using it quickly. And then with just a couple of commands in particular, right? We run cabal update, we run cabal REPL, we load the compiler we want, and then we simply run a function to get the output. Okay, so this is the same process that has been followed in previous versions of this course. It's just streamlined a bit so that it's all happening on Demeter first. And hopefully the starter kit really helps people move even faster just to be able to take a look at this. This video is probably about as long as a video needs to be. I think it was, yeah, 23 and a half minutes on this video. That's pretty long for a single lesson, but there was a lot to cover. And I'm eager to know if this is helpful to folks. So if you haven't taken a look, take a look there and let's continue to refine this content. Any questions about lesson 101.1 and what we have here? Yeah, Sebastian, what do you think?
Yeah, one of the novelties in this lesson is also the use of the faucet contract instead of the traditional always succeeds uh, contract. My question is, I'm in charge of the lessons 102.2 and 102.3. Build your instructions, those. And I was thinking on using the always succeeds, but after watch the video and the lesson, I conclude that the line of thought is going into using this faucet. I don't know if I'm correct, but my question really is, should I use this the faucet count to demonstrate the transactions, the locking and unlocking transactions? That's my question.
Awesome.
I was thinking that maybe I was thinking on using the always succeeds, because the faucet is a contract with a specific goal, and maybe using in for other things can affect the functionality of the contract. But after I took the lesson, I'm a little bit confused about it. I have to decide. So that's my question. Should I use this contract or the always succeeds?
This is
Or
this is
build another?
Yeah, this is such a
Yeah.
critical question. This is such an important question. Thank you. And
Yes, and
it,
because the lesson describes the use of the contract in the one of the lessons in the one of the module. So
yeah, good.
yeah,
So I
that's it.
mentioned that one piece of feedback we got about last year's course is that the process of setting up your local Plutus TX development environment is a blocker for a lot of people. So we took action in response to that. Another piece of feedback we've gotten is that the always succeeds validator is actually too simple for people to understand some important ideas, right? So we show people how to use it, but people were actually more confused after we showed them always succeeds because it didn't help them understand what the validator was actually doing. It was just always succeeding. And that's why we made the design decision in this year's course to start from the faucet validator right away. It does a little bit more than always succeeds. It actually has some validation logic, but by virtue of having that validation logic, a lot of important concepts actually made a lot more sense. So yeah, I would recommend that we make these two lessons about the faucet. I think this can be done. I think we can get people there. And I would love to support that. There's some ways we can do this. And maybe we'll even have time at the end of today's lesson to look at some of those details to put that story together.
Okay. Okay. Because
Nelson,
one of the in the past, yes, in the past. Oh no, okay, I'm rambling.
yeah, no,
Thanks.
this is it. This is so important. And actually, it does call out you had a question about the order of these two learning targets. And I was thinking about it more. And I do think unlocking makes sense first. So one of the things we did last year is we had people mint their access token, then send it to their CLI wallet for the first time. And we can do exactly the same thing here, right? So people are already interacting, they're making a successful transaction in lesson 100.5. And then we can show them in lesson 102.2 how to build basically the exact same transaction by sending their token from their browser wallet to a CLI wallet. And then finally, locking is actually a little bit more advanced and actually pretty interesting. So we can then look at this one together and see how that step is going to work. So yeah, I think this can be done.
Okay, we can talk later
Yeah, let's keep
on
going on
this.
that. That's a thrilling conversation. Nelson, what are you thinking?
Yeah, I have a concern about the transaction getting too complicated if we are using the faucet with all of the 5 validation logic. If someone is trying to build their first transaction and has to go through, everything right at the first time, that might be a point where they get, this is too hard. So uh, right now our validator has like 5 uh, different validation logics. It introduces a new concept of additional tokens with respect to like the Cardano faucet we have, it's like data only. So it's like, but here we're introducing another token too. So the transaction for building it the first time, I think all of the validation logic will complicate the transaction for someone building it first.
That's a really good point. And actually, I was thinking about that while creating lesson 101.1 yesterday. And let's take a look at this source code for just a second so we can frame this, because you're exactly right. There is a lot of logic here. But what we have, and let's just look together at those 5 constraints that Nelson was just talking about. So this is the validator code. And there's 5 things we're checking. Input has access token, output has that token, and output has faucet token. The faucet contract gets the remaining tokens, and the datum cannot change. What I was thinking for lesson 102.2 is actually we can show people how to build this transaction, getting each of these things wrong one at a time. And in the video for this lesson, people would actually see each of these errors one by one at the stage of transaction build. And so I don't want to leave people to do this whole thing on their own the first time they're ever doing anything, but it gives us a really nice chance to look at this logic, right? And anybody who's gone deep into Cardano development, this logic can get really advanced. But I think that these 5 things are explainable enough, right? Input has access token, right? Well, does it or does it not? And so on and so forth. So I'm thinking we can make a lesson, like I just said, where we show each of those. Maybe we would want to split it up into 2 parts, because that could turn out to be a pretty long lesson. But could you imagine that?
Yeah, for me, stepping into the shoes of, coming in, building my first transaction after I tried to get my understanding on UTXO, I think this is too big for, for me being in that shoes for the first time. So, yeah.
What if we added one learning target? Tell me how much of a difference this would make. What if we did this? Because one thing you said does really resonate with me, which is, if you're trying to learn about validators and native assets at the same time, that could be pretty overwhelming. What if in between learning target 1 and 2, we added one about sending native assets in a transaction right here? Would that ease some of the burden that's on lesson 102.2 right now?
I think so. Yeah.
Let's just imagine that, right? Because we can still, so I can send a transaction that includes native assets. And there might still be a little bit of revision that we have to do here, but this is one thing that would just confuse people a little bit less, right? Okay, simple transaction. Choose one UTXO, send it somewhere else. Great. Now let's make a slightly more complex transaction where you're selecting a UTXO that has some other assets in it. We send that. Okay, cool. Now that you've done both of those things, now we're going to talk about how to unlock from a validator. Maybe there's some other intermediate things we'd want to do first. So anybody else as well, like what Nelson is sharing, right? We're trying to maybe do too much if we jump into this learning target too soon. So we can extract those things. And we could say, all right, well, let's cover native assets first before this. Is there anything else that we would want to separate and kind of put in between learning target 1 and 3 right here to show people first?
Yeah, I think between the situation scales similarly from 1 to 2. People start sending simple, building a simple transaction, and then with ADAs or some simple and well-known tokens, and then they go to send other kind of native or kind of tokens. I think it's a good way to guide the people through the experience.
Let's start with this, and let's start building these lessons. And as we build the lessons, if we discover things, it's not always a perfect rule of thumb, but as a content writer, if you find that the lesson is getting really long, it's usually a good evidence that maybe that lesson can be split up into a few smaller parts so we don't overwhelm people. I propose that we get started with an order like this, but we just pay attention to how it feels. And if we need to break things apart, we will.
Yeah, just chiming in for like the length of the lesson is a good thing, but then really listening or providing a listening to the students as they go through and really watching. I think that's kind of like that game testing. Are people kind of getting stuck in one level? And then figuring out what the the cognitive, like what's holding them up. And it could be that there's some concepts that need to be introduced in a different way. But there is a leap. That's the learning. That's what happens in learning. Is the leap too much? And so it's a great question, is how to break things down so that it's digestible and it flows in the right pattern. Because if the first lesson is super easy and it's just like, oh yeah, I did this in 15 minutes without much cognitive thought, intellectual heavy lifting, and then the second one is just like opaque and like, oh crap, I've got to do all this extra research, and then it could be the shut off switch. So yeah.
That's a really good way to thank you, Newman. Yeah, like it's not just about the absolute challenge of a lesson, it's about the relative challenge from one to the next. And if
Yes.
there's too big a discrepancy, that's really hard to deal with. I love that. Yeah. Nelson, what do you think?
Just realizing now, there's nowhere we have introduced installation of Cardano Node and Cardano CLI.
Yeah. That was gonna be here as all just in previous years, that's all just been part of this same lesson. But this lesson as well can be split up into multiple parts, right? The journey towards building your first simple transaction does involve several steps. On the other hand, it's possible to skip those steps and do them directly into Meter.
Yeah, we can still use Cardano CLI in Demeter. You just run it in Demeter, right?
Okay. So this is shaping up nicely. So when we get to open spaces tomorrow, one thing that I'll propose for a breakout room is a jam session on module 102, really outlining this thing and thinking about how we want to, like, making formal decisions about how we want to tackle each of these lessons and if anything needs to be changed. That's cool.
Nice.
Wow, this already feels different than in years past. This is really cool just to be having these conversations in the first place. Thank you, guys. So going back to the course, let's look at once again those just what we have here in the repo, right? So in addition to just the count of these 5 things, we need to help people understand this logic, and they'll see it as they work through lesson 101.1. But all we're really focused on is just showing people how to open up the REPL, how to load a Haskell module, and then how to run a function from one of those modules, which spits out the on-chain code, okay? The byte string and the .plutus file that can be used on the blockchain. Why does this matter? Well, when we look at this right here, and then people move to the very next lesson, right? They go from compiling the Faucet validator from Plutus TX in Demeter. The very next lesson, it's still compiling a similar validator, but from Aiken and doing it locally, all right? What's cool about the Aiken code, which, by the way, we can find it in the same place. Let's go. Once again, just to make sure people have the whole flow here at the Plutus PBL website, there's a set of course repositories. This one is also linked directly from the lesson right here, right? So you can use this link, or there's always this set of links which can be updated over time right here. We can jump into the Aiken example. We can look at the Faucet example right here. We can jump into the validator, and lo and behold, we can see 5 similar checks right here. And this is a key idea. Now, there's some Easter eggs here. The logic for each of these is actually not exactly the same. And that's what's going to allow us to show people some interesting details about how UTXOs and transactions work. But more on that tomorrow and next week. At a high level, the outline of this is the same. The datum has to match. Yeah, we saw that, right? There has to be Faucet output, and the Faucet has to get those remaining tokens, and then something about a token to the sender. The way the logic is implemented is a little bit different. So we have the ability to just show people, right, that there's some creativity necessary when you're building a validator, but at a high level, we have a similar structure here, okay? From a story perspective, how's this sounding to everybody? Moving from looking at Plutus TX on Demeter into a similar validator in Aiken. So far, so good? Okay. So is it cool if we jump in? What you'll see is that lesson 101 has a video. Lesson 101.4, for example, has a video. Nelson made this one. But for lessons 2 and 3, we don't have the videos yet. So I was hoping that maybe we could use some time right here, and then we can just cut today's recording and put it here as the video for this lesson. Does that sound okay?
Very cool.
All right, let's give this a try. So I am sharing a browser, but not the whole screen. So I'm going to have to jump to VS Code in just a minute. But let's cut from this moment right here and welcome people to this lesson. So hey, and welcome to a lesson about Learning Target 101.2 in PPBL 2024. In this lesson, we're going to cover compiling the the PPBL Faucet validator. You saw something similar to this in the previous lesson, but this time we're going to do it from a language called Aiken. And you can see an outline of this lesson here on the page, and I invite you to follow with these steps. And that's exactly what we're going to do today, okay? Now, this video feels a little bit different from the last one because this one is being recorded at our live coding session, which meets every Wednesday at 14:30 UTC. If you're interested in joining up for this meeting, you can find all the details you need at plutuspbl.io. Click on live sessions on the top of the page, whoops, and you can navigate to our calendar where you can find links to meetings like this one. You can see a Zoom registration link, for example, right here. So what's Aiken? Well, it's an alternative to Plutus TX. And I don't know, has anybody else here heard any mudslinging between, Plutus TX and Aiken camps? Or has Aiken already won? Is everybody just going the Aiken direction? Maybe. All right. There's an ongoing debate about which of these languages is better or which one people should use. And one thing you got to understand about this course is that we want you to decide for yourself. If you want to go out there and participate in the debate, that's great. We're going to give you evidence for either side, but we're not going to try to tell you what to think. Okay, that's up to you to decide which side you're on. But hopefully this course gives you some evidence about what you like about Plutus TX and what you like more about Aiken and vice versa. So we're going to go step by step through the process of running Aiken. And one advantage that's really clear about Aiken is that it is easier to set up an Aiken dev environment on your own computer. Plutus TX has a large amount of overhead, and we've met a lot of people over the last few years for whom that can be a blocker to getting started. And if you've ever heard people saying, Plutus is too hard or Haskell is too hard, a lot of those people, what they're talking about is just that setup step, just getting started. So score 1 for Aiken here on the process of getting started, but also score 1 for the entire Cardano developer community, because now we have tools like Demeter that make it much easier to get started using Plutus TX. And we encourage you to take a look at the previous lesson if you haven't done that already. Now, there are resources on Demeter that you can use to run Aiken on a virtual machine and access in your browser, just like we did in 101.1. But I really do encourage everybody to try to set up Aiken on their own device. And to do so, you can follow the installation instructions that are linked right here. There's a few different ways to do this. The Aiken team provides a tool called AkeUp. This is a little bit like NVM for people who are familiar with that on node development. It just manages your versions of Aiken for you very quickly. So you can install AkeUp and use that. Or you can follow any of these processes right here. Aiken can be installed via NPM, Homebrew, or if you have a Rust toolkit installed on your device, the Rust package manager is called Cargo, and you can use this one. Also, if you like the Nix approach, if you're coming from Plutus TX development and you have Nix set up, for example, you can use this option right here. Now, there's another thing to understand about this Plutus PBL course. That's all I'm going to show you about installing Aiken. And we're going to leave it to you to read this documentation and try to get it working. If you do get it working, you'll know that you were successful because you'll be able to jump over to your terminal and type Aiken -- version. And you'll be able to see that the current version of Aiken is installed, which as of today is version 1.0.26-alpha. We can confirm this on the releases page for Aiken here on GitHub. If you get stuck at any point, there's a few options. We hope that you'll reach out on the Gimbalabs Discord server, or that you'll drop by one of these live coding sessions, okay? Even though we're not going to hold your hand every step of the way in this video to show you how to install Aiken, if you get stuck, we absolutely want to help you out. And that's a pattern you're going to see over and over again in this course. Our goal is to provide little places where people might get productively stuck. Teachers like to call this productive struggle, okay? A struggle can be demoralizing if it lasts for a long time, but we all know this, right? To learn really important lessons, a little bit of struggle can come in handy, okay? We want you to get stuck, struggle a little bit, and then we want to help you get unstuck. So let me switch windows here. And for the rest of this lesson, I'm going to be following the documentation that's here on the page, but I'm going to be doing so from my VS Code window. Let's jump over there. Share Visual Studio Code. All right, right here, you can see a couple of things. First of all, let's just make sure that I do indeed have Aiken installed. Aiken -- version. And you can see right here, I have version 1.026-alpha. Not sure why there's an unknown release tag right here. I have to double check on that. But as of today, this is working for me. Now, I've also already run the command git clone for this repo. You'll find the link below this video in the lesson, okay? So I've already run a command that looks like this. Let's just grab it. Okay, I'm not going to run this again, but this is what you would want to do: git clone the example repo. And once you do, you'll be able to CD into it, okay? So I have a couple of projects on this device. I just git cloned this one, and here we are. Now in here, there's only a couple of directories, and I want to look at really the only one there is so far, PPBL Faucet. We're going to add other examples to this repository later in the course, but for now, this is the one you need. So let's CD into that one as well. Great. Let's also look at that directory over here. This is a standard and pretty minimal Aiken project setup. I have an aiken.toml file that provides some metadata and some dependencies about the project. If you're familiar with JavaScript, for example, this is kind of like your package.json file right here. And it's accompanied by a lock file that's similar to lock files that you could find in many other platforms, right? So if I have a package.json file in JavaScript, I might have a package.json lock file as well. README, git ignore, standard stuff. And the most important thing to see is this validators directory right here. If you took a look at the prior lesson, 101.1, you're starting to be familiar with this word, validators. A validator holds the code for how transactions can succeed or fail on Cardano. More specifically, it helps us write the custom rules for how individual UTXOs can be unlocked from validator addresses. Now, there's a lot more to talk about there. And in the next module, we're going to jump in to transaction building, which is going to help a lot of these pieces come together. But for now, I hope that on your own time, you'll take a look in detail at this validator. Try to compare it to the code we looked at in the previous lesson, because you'll find a lot of similarities. You'll find datum that looks similar, a faucet redeemer that looks similar, and you might be looking for something called faucet params. If you're really paying attention, we won't see those exactly the same way. They don't get a name in this case, but we can just put them right here, okay? And we could extract these out and make a type as well. There's a few different ways to do this, okay? But for now, just notice that the parameters get passed to this validator function as arguments. This looks familiar from a lot of different languages, right? 2 comma separated arguments inside the parentheses of our function call. What's in the body of this validator is a function called PPBL Faucet. We could call it anything, and it takes 3 arguments that look very similar to the faucet we saw in the previous lesson: datum, redeemer, and context. We're going to look at all of this in depth over the next few lessons, but for now, just recognize the similarities between this code and what we've looked at previously. I'm going to skip over a lot of these details because this is what we're going to, again, dive deeper into soon. But at the very end, I want you to see that just like in Plutus TX, there's a set of Boolean statements that must all be true in order for this validator to succeed. Some of these match the Boolean functions that we looked at in Plutus TX in the prior lesson, but some of them are a little bit different. And those details start to get really interesting. When we start building some transactions in the next module, we're going to look at some of those details in depth. But just like in the last lesson, before we can even think about transaction building, we have to be able to compile this code right here into a format that can actually be used on the blockchain, right? If I tried to upload this PPBL Faucet.ak file to the blockchain, it wouldn't do me any good. First, I have to compile this code into a byte string format, right? This can be translated into a CBOR string, which is a type of byte string that encodes the logic of this validator. And you might often hear the term UPLC, untyped Plutus core, when it comes to on-chain code. And this is really interesting. No matter what language we're starting from, Plutus TX, Aiken, or as you'll see in the next few lessons, Helios and PluTS, all of those languages compile to the same target. The compilation target is UPLC, untyped Plutus core. And this is, right, the encoded format of that is what we're able to use on the blockchain itself. How do we get there? I'm going to open up a terminal window, and I'm going to open up my file explorer because we're going to be able to watch a couple things change over here. First of all, anytime you want to, you can run Aiken check just to type check your code, and you can see that this code has no errors and no warnings in it. That's a good sign. Great. A wonderful thing about Aiken is that the error messages and the warnings are really helpful. They actually have some personality, and they suggest ways for you to try to fix those errors and those warnings. And we'll take a look at those in a couple of lessons really soon. For now, good. We're happy that Aiken check worked. Now let's run Aiken build. What this is going to do is take our source code and output a new file right here called plutus.json. This is called a blueprint file. It has some metadata about the contract. Here's the title. Here's a description. Right? We have the version and which version of Plutus. We have which version of Aiken. They're calling Aiken our compiler because that's what's getting us to our target, which is Plutus v2. And then we have a list of validators. Cool. We got some validators. We've got some helpful definitions in the rest of this file. Let's look at those validators. There's only one. Okay, so validators is a list because a lot of applications will have multiple validators. This one only has one. What's the title of this one? PPBL Faucet dot PPBL Faucet. Very good. Then we've got schema for these things called datum and redeemer. And if we scroll down below to see these definitions, maybe if you've been following along closely, these definitions will not surprise you. The type of faucet datum included a withdrawal amount, which is an integer, and a faucet token name, which is a string. Here we call it a byte array for reasons that are a tiny bit beyond the scope of this lesson. We're going to talk more about this when we start building transactions. But for now, this is the way to represent a string when we start writing on-chain code, okay? We have this thing called redeemer that also matches the type of the faucet redeemer. We've got a sender pub key hash and an access token name. We also have compiled code already, but that's a tiny bit of an incomplete story. This compiled code is only going to work if we first apply these parameters to it. And in the previous lesson, we showed you how to apply parameters to a validator in Plutus TX. Now we're going to look at this a slightly different way and see one way to approach this in Aiken. We've got two parameters. They're the same parameters from last time. We need the symbol of an access token and the symbol of a faucet token. Then we've got to apply them here. Now, I said, will this work? What do I mean by that? Let's try something here. Aiken Blueprint provides us with a couple of different commands that we can use to interact with this blueprint file. Okay, and once again, this file called plutus.json is called our blueprint. We can try to derive an address from this, a policy ID, a hash, or we can try to convert this into another format. You're going to learn a lot more about validator addresses when we start building transactions. But just as an example, watch this. Aiken blueprint. Let's just write address and see what happens. Notice that I got an error. Blueprint address parameterized. I couldn't compute the address of the given validator because it's parameterized by two parameters. Exclamation point. I told you, these error messages, they've got some personality. I can only compute addresses of validators that are fully applied. Okay. And this is missing two of them. Applying parameters changes the validator's compiled code and thus the address. And that's why I need you to apply parameters first using this command. Okay. So I see that that doesn't work. What about another one that we're going to use in just a minute? Am I able to convert this to another format? That's interesting. So I can see a file that looks kind of similar to the output file that we got in the previous lesson. But once again, this is not going to work because it doesn't have the parameters applied. And that's something we can look at more over the next few lessons. Let's see if we can apply parameters to the point where this address function works. Okay. And so we have an option called apply right here. Let's try that. Aiken blueprint apply. All right, it prompts me right here in my terminal for an access token symbol. Okay, let's switch windows for just a second. I'm just going to go over to GitHub and open up the code that we were looking at in lesson 101.1 so we can see these same parameters are here. So here's the compiler that we used for the faucet from Plutus TX, and these parameters were applied at this function step, right? We can write a function for this. You could actually write a function that does this as well for Aiken, but I just want you to get a feel for these different ways, right? I want you to see that a validator can be partially compiled without parameters. A lot of really interesting stuff is going to follow from here. And so we're already starting to look at our different options. But this is what's interesting to us. The access token symbol is right here. The faucet token symbol is right here. Let's just copy and paste this access token symbol over to VS Code. And watch how the Plutus.json file gets updated. Watch closely here. I'm going to try to minimize my terminal so you can see. Watch these parameters and watch the compiled code when I paste this policy ID and then press enter. We're going to be overwrite. Oh no, hold on, wait a minute. I forgot to do one thing. And this is in the lesson, you'll see this. I shouldn't have written Aiken blueprint apply. I should have written Aiken blueprint apply -O for output and then Plutus.json because I want to overwrite the existing blueprint file with the results of what I'm about to do. Okay. All right, now we're going to be able to watch this file and we're going to be able to see it change dynamically. Same prompt, give me an access token symbol, paste it here, and I'm going to press enter. What just happened? Well, it says it applied this. Now, it says it applied 581C903. Is that exactly what I typed right here? It looks pretty close, but do you notice the difference? A couple extra characters at the beginning. That's kind of interesting. All right, keep that in mind. We'll talk more about that a couple weeks from now. But also notice up here, now this blueprint file, the compiled code is a little bit longer than it was a second ago, and there's only one parameter left. Now, I still can't run Aiken blueprint address. I still get an error, but now it's only missing one parameter. So let's try it one more time. Let's run blueprint apply on this file. Last time we were prompted for the access token symbol, but watch what happens this time. We're prompted for the faucet token symbol. I'm not going to share screen. You guys just saw this in my browser that we had the faucet token symbol in the Plutus repo. So I'm just copying and pasting from there. We can apply this. Once again, watch the parameters, watch the compiled code, and also watch line 37, the hash. Ready? Okay. No parameters left. Compiled code is even a tiny bit longer, and the hash was just updated. Now that we have no parameters left, let's try this address command one more time. Aha, this generates an address that can be used on the blockchain. How do you use this address? That's what module 102 is about. For now, the work is done. We have a compiled validator with parameters applied from Aiken. So finally, if I run Aiken blueprint convert one more time, I'll see something that might look familiar once again from the previous lesson. And what I'm going to do here is I'm just going to create an output folder for myself, output, just like I had in my Plutus TX repo. I'm going to make a new file here called Aiken PPBL Faucet, and I'm going to call it .plutus. And I'm just going to copy this right here into that file. Now I have a Plutus script that can be used on chain with the byte string right here that looks very, at least in terms of its shape, it looks very similar to the one we see here. Plutus examples, output, my faucet script.plutus, and the text isn't wrapping here on this version, but you can see that the shape is the same. All right, this is what an on-chain Plutus script looks like, and this is a file that we can have all sorts of fun with in the next module. Anybody have questions about that? Thanks for hanging out for that. I appreciate the chance to do this live. What are you thinking? Thanks for the emojis, guys. Anybody have any questions? Anybody stuck on any of the details I just shared?
It is great to see you do the instruction. It flows well for me. There's a couple things that like I haven't really seen Aiken work like that. All those commands. Yeah, I mean, there's a few things like the terminology, and I've got this sort of idea of a glossary, and because those are like the low hanging fruit. Like if you can, it's just a rote memorization type of. If you put in this effort to learn these terms, they do pay off. So I think about that, and then there were a couple of things like really well done, and I think that'll make a great instruction video on that SLT.
Thank you, man.
Yeah.
I love the idea of a glossary. And it's one of those things, it's kind of like too big to think about where to start. So any
Sure.
idea, yeah, that's all ears for all the ideas you've got about that. That's really cool.
Yeah.
Harsha, what do you think?
I just have a basic question. So I can create technically a smart contract without running a node, just using Aiken?
Very good question. Exactly. Okay. Nodes are for transactions, right? Nodes get us information about the blockchain, and they help us submit valid transactions. But the validator code itself doesn't require any access to a node. And that's true for Plutus TX as well, right? You can write all of it offline. It's just that to actually use it, now you need the node. But the step of writing it, yep, no need to connect to any network. that makes me want to make sure that people understand that, because we haven't covered that sufficiently, and seeing the distinction between the writing of on-chain code and the using of the blockchain itself. Yeah, if we're not helping people get there, then I can imagine a lot of confusion would follow.
And that goes back to that basic mental model of what's going on, you know. Right.
Yeah. We need pictures. You won't be surprised to hear I'm kind of a verbal thinker.
Sure.
I've never been the one to be able to draw a picture that makes a ton of sense. And so anybody here has pictures in their mind of how to tell these stories in an effective way, I would love to see better ways to visualize some of these mental models, because there's what's the saying, right? How many words can you fit in a picture?
Right, right.
Right, like this is it, and that's so important, especially if our goal is to help people build robust mental models. Martin, what do you think?
Well, it's funny that you say you're completely verbal. I'm kind of like the other way around. Like the pictures I see are hard to translate into words. So that's how I tend to communicate. So maybe I can help there.
Yeah.
And just from a purely idealistic perspective, right? Like if the goal is to help people learn, how do you do that, without a diverse staff of teachers in the first place? It's in everybody's best interest to make sure that there's lots of different ways of communicating these things moving forward. So yeah, my dream for this team is for us to like I can, like, I'm never going to take, like, if you guys say, oh, that lesson was crap, let's get rid of it, that's never going to hurt my feelings. Like, yeah, good, like, good, thank you, please say that. And I hope we can build a team where we can point out to each other like what's working, what's not, and where it needs to be improved, right? Because like I just talked for a long time on that lesson, right? And it'll be effective for some people, but not for everybody, right? So what are the other approaches we need? We're just on the beginning edge of being able to look at that view of things, right? And really providing as many options as possible. And the bell is ringing. That's right. Hey, we are underway. We never have to do the first live coding of PPBL 2024 because now we've done it. And I'm so excited to just get into this rhythm, take it through the summer, and see where we go over the next few months. So thank you, everybody. We got the open spaces tomorrow, and we'll continue over the next few weeks, see where all this goes.
Thanks, everybody.
Appreciate you being here today. See you soon.
Bye.